Hey, hope you're having a good day or night, depending on when you're listening to this or watching this. By the end of this video, what we'll be having is a payment service which will allow clients of our application to buy things such as shoes, in this example, shoes and pens. Alright, so let's look at the architecture first. So we have our front-end app, which can be anything really, a web app or desktop or mobile app, whichever you want. And we have our payment API. So this will handle things such as communicating with the payment servers and also the database servers. And our database servers will be interacting with Cloud Firestore. Now coming over to the programming languages we'll be using here. For the front end, I'll be using Kivy, and for the payment API, we'll be using Ballerina, and for the database servers, okay, we will not be covering this in this video, but that will be in Flask. Flask, Python, yeah, that. So you may ask, why am I using Ballerina and not maybe Flask or Spring or Node.js? Well, really, at the end of the day, the programming language is just a tool. And in this case, I find that Ballerina seems to be the best option at the moment. Alright, so the first thing we're going to do is define our HTTP clients. So all we're doing now, we're just defining them and no connection is made at this point yet. So we'll go ahead and define a service called Sprinkle in this case, and we'll define where it will listen to on our computer. Inside it, we'll create a resource, create order, which is where we'll allow people to, or allow the application to create orders, no pun intended. And also we'll limit its methods to post only. Now, what helped me understand this concept of service and resource is I thought of it in the way of classes. So we have our service as a class, Sprinkle, and we have create order, our function or method in this case. That helped me understand this properly. So what we want to do now is forward the request to the database endpoint, to the database service. And now, as you can see, the request is a red squiggly line under it. Now what that means is the data is untrusted, because think of it, we're getting data from a client. We can never trust data from a client. It's possible it's some nasty stuff in there, so it needs to be cleaned. And the language itself, Ballerina, won't let us pass that untrusted data anyway. So for us to tell Ballerina that, yo, it's okay, Ballerina, this data is clean, you can trust it, we add the untainted keyword. Now, if you want to be more explicit about your types, Ballerina has union types, so you can decide how the program should react or behave in case the request went through properly or maybe an error happened. You can do that too. And perhaps if an error occurred, then you can roll back some kind of transaction you were doing. So we'll go ahead and grab the payload and just send it back to the client as it is. Now, to keep the code a bit more clean, I'll be using the check keyword. You may not want to use this for production purposes in production, just to be clear of your responses, of the responses you might get. So the check keyword will ensure that, or will tell Ballerina that, yes, Ballerina, this thing right here, it will always go through correctly. Like no possible error may arise here. And if you look in the function signature is that we add the error and then question mark keyword. So it's sort of like, yo, will this return an error? Or maybe it may return an error, question mark. Man, this thing was funny when I was learning it. But then yeah, it just means there's a possibility that if this function or resource may return an error. Now the compiler says we need to add the tainted keyword in our signature there at the return. I'm not so certain why this is happening. Honestly, I don't. Why we need that. Yes, the result of using the check keyword, we're able to bring down the lines of code to 3. We'll go ahead and run this program so we can test out the create order function resource. But before we send anything, let's quickly look at our database. So in our database we have products and we are only going to be selling 2 today. So it's shoes and pants, that's it. Now disclaimer, this may not be the best way to design your NoSQL database, or should I say to structure it out. So let's open up Postman and send a post request. If we go ahead and look at our database, you can see that the order was successfully created. Moving back to the code, the next resource we'll be working on is the start transaction resource. Now what this will do is warm up a few things with the payment gateway and also interact with our database servers. So we'll go ahead and grab the body and just convert it into a map. Now if Ballerina failed, if the check failed to convert the payload into JSON format, then the method will fail there and it won't proceed further. So we go ahead and grab the user ID and then use that, pass it to our database endpoint so it calculates how much exactly the order cost is worth. Now reason we don't want to get the cost from the client is, it's kind of obvious, never trust the client and you always want to calculate it yourself on the back end. The following is things we will pass to the Paygate API. So the UUID is just something random which we'll use on our end to specify this or to identify this transaction out of all the others we may be having. Now, thanks to Ballerina's interoperability with Java, we go ahead and call the create random UUID method, the Java's one, straight from Ballerina. I know it's amazing. So we'll go ahead and have a map which will be passed on to Paygate's API. Now the amount we'll be using is 3299 because that's the one used when you're testing, of course. And we'll have to generate a checksum and we'll just create a method for that, a function for that. We'll go ahead and assemble or build up a request object which we'll send over to Paygate. So the payload will set it to our map, but then again this map, Paygate expects it to be a form, and Ballerina doesn't necessarily have a way, or at least as far as I know, a way to convert our map to form data. So we'll just create this method for ourselves, or function to convert the map into a form, and it shouldn't be difficult. Now we'll go ahead and convert the data that we get from a map from form data to a map, and we just want to make sure that no error has occurred. Otherwise, if it has occurred, then we just respond back to our client that, yo, listen, an error occurred. But otherwise, we go ahead and save this information so far that we have to our database, or where we'll use it further on later on. Now we'll construct the message we'll be sending back over to the client Now the client needs to open this in a web view or web browser, wherever, where they'll be redirected to the pay gates page, where they'll be able to do the transaction. And just to make sure that the client actually got the data, we'll confirm that, if an error occurred, your database canceled this transaction we initiated. Now we'll go ahead and define our return URL, or should I say the callback URL, where Paygate will redirect the client whether the transaction was successful or maybe perhaps they have cancelled it. This is where the client will be redirected to. What we'll do in here is simply return an HTML page where we just show the client the status of the transaction and tell them to close the page and return to the application. Let's go ahead and build out the notify endpoint. This endpoint will be called by Paygate before the client is redirected. And in here, all we'll do is confirm that the transaction really was successful and return an OK. So after we determine that the transaction is successful or the status of it and the code is correct, it went through, we'll tell the database servers that your database servers, the transaction went through and mark it as complete. Now, as for the application, I've decided to make a simple Kivy application to test this out, which simply has 3 buttons: create order, start transaction, check if the transaction is complete, and also some text label to show what is going to tell the user just to show us what is going on, right? If we go ahead and look at the create order method, all we're really doing is passing on the data to our API to create the order and simply display the output that we get in the status label. If we go ahead and look at the start transaction method, we pass on the data to the API, and what we do with the data with the response is we take the transaction reference. Now this is needed by the backend to sort of identify this transaction from all the others that could be taking place, and all we do with this is store it on the device in the meantime by using the storage object, so that in case the user of the application was to close, when we return back to it, we can still continue with this transaction later on. After saving that, we simply load up the HTML form and open it up in the web browser. And then we have our isTransactionComplete method. Now, if you're to build a mobile application, you may not want, or if you're building your application, you may not want the user to click the isTransactionComplete button. Now, what you can do is on mobile is we have the onResume method, which is called whenever the user returns to the application. Now, remember, the user is taken to a web browser. Now, when they close out of that and return to the application, this method will be called. So if we go ahead and run it, we can start off with creating an order. And if we look in our database, the transaction should be there, or the order should be there. Good. Now let's go ahead and click on start the transaction. Now what this will do is redirect the client or open the web browser where the client will be requested to enter their card details or whatever payment method was chosen. In this case, I chose credit card. Now this card number, these are the testing ones. And if we proceed, we will see that the transaction was approved. Now we may go back to our client and check if the transaction was complete or not. And there we see it was complete. And just to confirm, let's look in our database, and there we go, the order was complete.